I'm gonna hand you lab 11. You're gonna take the instructions and the data sheet. And you're gonna bring it back on Monday.
Let's go.
Or chapter 11.
Really? I love it.
Let's see. What are your feet? 17.
17? Oh, we actually caught up to what is it?
Oh, wait, I didn't Oh, it's so broken. Okay, so you have the instructions.
Is this going to be partner or single?
This is going to be partner. All right, let's go over the lab 11. So let's just talk through what you're going to do. I'm going to show you also what you're going to do. So in lab 11, let's outline. You're going to do a titration. You're actually going to do two different types of titrations. The first one is called a standardization. And the instructions for the standardization titration are in the lab 11 instructions for procedure. So we go to procedure, your standardization of base. What that means is I've made some sodium hydroxide solution, okay, and I think that it's 0.1 molar based on what I measured out, but maybe I added a little bit more water, or maybe the sodium hydroxide collected some water while it's been sitting. So we need to standardize it. That means we need to check and make sure it's actually 0.1 molar, okay? Or if it's not 0.1 molar, we need to use the correct value, okay? So this is about 0.1 molar. We need to standardize it so we know that the point of this is to know the exact concentration of NaOH. So right now it's about we think it's about 0.1 molar sodium hydroxide, but we don't know if it's actually 0.1. Does that make sense? So the way we're going to do that is you're going to use KHP. So hurry and look at your instructions. This is KHP, and we need to know this for a minute later, okay? So this does not just have potassium, hydrogen, and phosphate. It also has oxygens. It has 4 oxygens. It has 6 carbons. So this is not just KHP. The biggest problem last year, I don't think it'll be a problem this year, but the biggest problem last year with this lab is that people kept thinking that KHP was KHP, and they added that as a molar mass, okay? If we look up the molar mass, oh, it's right here. Perfect. The molar mass is 204.22 grams per mole, okay? So we're going to need to know that. Perfect. I didn't realize they gave that to us. So molar mass is 204.22 grams for 1 mole. All right, so that's the first titration. You're going to do 3 of these. You're going to titrate KHP 3 times. The reason why we use KHP is if we look at this chemical formula, we can look right here. We have this hydrogen, and this hydrogen reacts with sodium hydroxide in a 1-to-1 ratio, molar ratio, to give us something that's neutral. Okay. So that is the key to a titration. We need to know exactly how many KHPs we have, and then we'll use some sodium hydroxide. That will, knowing exactly the amount of KHP we use, will tell us exactly how much sodium hydroxide we use, and that way we can figure out the exact concentration of the sodium hydroxide. Okay. So the first section, you're going to weigh out KHP. We'll calculate how much it's going to be for the pre-lab, but you're going to weigh about 0.3 grams. You're going to write down exactly how much you use. You're going to titrate the KHP following the procedure, and then you'll be able to figure out how much the concentration of the sodium hydroxide is. Okay, so that's the first titration. The second kind of titration is you're titrating an unknown concentration. Titrate unknown concentration. So the unknown that we're going to use, it's not really an unknown, but we don't know the concentration, so the concentration is unknown, is vinegar. So the point of this lab is we're trying to find out what is the concentration of vinegar. Okay, so the acid in vinegar is acetic acid. And it's also a 1-to-1 ratio with sodium hydroxide. So once we know exactly the concentration of sodium hydroxide, we can titrate acetic acid and then use the concentration of sodium hydroxide to figure out the concentration of acetic acid. Okay, so we're going to do this also 3 times. We're doing it 3 times so that we have a good number. Maybe we went too high one time, maybe we went too low. We're just trying to be consistent and get a good value. Okay. All right, for part 2, you have to write your own procedure. Okay, so maybe take some notes. I'm going to show you how to titrate. We're not going to, I think this one, you have the instructions. You can figure this one out. I'm going to show you how to titrate vinegar. I would take some notes. That's why this stuff is up here. Take some notes so that you can be ready to write your own procedure. I'm also going to give you another hint. We did this lab last year, but we did it from this book. They gave us the procedure last year. If you need help writing the procedure, you can look at lab 13 in this book. And there's some books scattered around, and we can get more out if you need. So I would like you to come prepared with that procedure for Monday. Okay, so let me put my safety glasses on. All right, so right now I have, let me turn this. I have my burette. You've used a burette before. Oh. Okay, so I have all these things up here. Right now my burette is filled with sodium hydroxide. So the titrant, whatever you're using to titrate is your titrant. That's going to go in the burette. We use the burette, remember we measure by difference. So pull out your data sheet. If you can see this. Part of your data sheet is you're going to write down the initial value for the sodium hydroxide. So wherever, remember how we measure from the bottom of that meniscus. I'm going to try to show you. Can you see that bubble? So we're going to measure from the bottom of the meniscus. As long as you're consistent, then that's good. I would always measure, that's how you're supposed to. You're supposed to measure from the bottom. So always do that. Okay, so your burette should be full of sodium hydroxide from the previous class. Okay. If it's not, if you ever have to start from a fresh burette, if it's not completely dry, you want to rinse it out with your titrant. You want to make sure that everything in here is your titrant. The goal of this lab, what I'm going to be looking for is a lot of sig figs. Make sure that you write the correct number of sig figs. And also it does matter that you get the right number in this lab. Part of chemistry is quantitative, and this lab is quantitative. We are trying to figure out the exact concentration of vinegar. Okay. So some chemists, that is their job. They are trying to actually figure out a good number instead of just like, oh, the thing changed colors or I made something new. This part of chemistry is the numbers do matter. We're trying to find exactly how much. Okay, so we need to be careful. So before I filled up this with base, it was full of water. So then I rinsed it a few times with some of my titrant to make sure that everything in here was my titrant. If there's a little bit of water, that might dilute my concentration, and that will give me a different number than the true number, okay? All right, so then we're going to use these Erlenmeyer flasks, and I've given you 3. So it is okay if you have water in these because we're going to be adding base and acid to these. And the important reaction that we're looking for is we're going to take some acid, which is either the KHP or the acetic acid. We're going to add sodium hydroxide. We're going to add this base. And these together are going to cancel out and make water, which is neutral. Okay? And the important thing is that it's a 1-to-1 ratio. Okay? So for every 1 hydrogen, I need 1 hydroxide. Okay? So if I have a little bit of water in my Erlenmeyer flask, it doesn't matter because that's not going to affect the hydrogen, that's not going to affect the hydroxide. Okay, water is neutral. Okay, so I'm going to prepare my vinegar solution. So I have some vinegar in this beaker. I'm going to close the door. If I just hydrate straight vinegar, it's going to be more concentrated than my 0.1 molar sodium hydroxide, and it's just going to take a lot of sodium hydroxide. So what I'm going to do is I'm going to dilute it, and that's what we did last year, and that worked really well. So what we're going to do is we're going to very carefully this is our called a burette. No, this is a pipette. This is a pipette. This pipette has a 0 line at the top, and at the bottom it's 10. So this one's calibrated to 10. It will give us 2 decimal places. So every time I use this, I'm going to fill it to 0, and that's going to be 10.00 milliliters. Okay. All right. So to use this, I'm going to push the bulb. I don't know if I need to do it here. And then I have an A button on the top. I'm going to push. And then what I'm going to do is if this has liquid, I'm going to run out of vinegar. So for my demonstration, I should do this. Let's see. I can go get more vinegar. All right, so it has a little bit of water in there. So I'm going to suck up a little bit of my vinegar. And I don't want anything else in here but vinegar, okay? Otherwise, it could dilute my concentration. I'm trying to be very careful. So I'm going to dump it out, maybe do that another time if I think that I need to get more, if I need to get more out of here. Okay, right now I feel good. I feel like I rinsed it out. Everything in here is vinegar. All right, so I'm going to put my pipette bulb back on there. I'm going to do my best to get no liquid in the pipette bulb. They will not last as long as if I get liquid in there. So do your best. Try not to get liquid in the pipette bulb. All right, so this is my vinegar. I'm going to dilute it. I'm going to use my volumetric flask to dilute the vinegar. I'm going to take 10 milliliters of my vinegar, and I'm going to dilute it to 100 milliliters. So remember the line on there? I don't know if you can see it. I'm going to dilute it to that line with distilled water. Okay, I'm going to pull liquid up into this bulb. The S button, I don't know. I think it's the suck button, I don't know. So it sucks liquid into there, and then I want the meniscus to be level with the line. So to me, that looks like, I don't know if you can tell that. To me, that looks like the bottom of the bubble is right on the 0 line. And I can play with the buttons until I get it right where I want it. And then I'm going to take this and put it into my volumetric flask. And I'm going to put the E button, I think that's the empty. And then I'm just going to let it drain. And then if there's any liquid on the tip, I'm going to make sure that transfers also. But I'm not gonna worry, I'm not gonna blow out this little liquid at the tip. This is designed so that a little bit of liquid stays in there, okay? It's calibrated to do that, so don't get that out, okay? So leave that there. All right, so now I have 10 milliliters in this volumetric flask. I'm going to dilute this to 100 milliliters. I'm doing this because the vinegar will be too concentrated. If I just titrate straight vinegar, it's going to take like 100 milliliters. Okay, that will take too long for us. So doing the dilution step will help us a lot. All right, so I'm going to fill it up a little bit. I'm going to stir it, mix it. And then I'm going to fill it up to the bottom of the neck. And then the rest of the way I want to be really careful, so I'm going to fill it with the squirt part. Probably not the technical name. All right, and then I'm going to be really careful at the very end, make sure that the line is right at the bottom of the meniscus. Okay. All right, so now I have 100 milliliters of my diluted vinegar. I need to write that down so that I remember. That's going to affect my calculations. I need to know how much vinegar I titrated. So I'm going to write that I took 10 milliliters and I diluted it to 100 milliliters. Okay, so the next thing I'm going to do is find a beaker. I need this beaker. Okay. And then I'm going to dump all of my solution into here, and I'm going to make sure that it's really mixed up really well, so that this is like all of my vinegar is distributed evenly, okay? And then what I'm going to do is I'm going to start, so this is my sample that I'm going to titrate. I'm going to titrate the diluted vinegar. Okay, so I'm going to take 10 milliliters of this sample. So I'm going to, first I have to clean my pipette, so I'm going to draw some up. So I'm going to evacuate. I'm going to draw some, oops, that's the wrong button, into the pipette. And I rinse it around, like kind of spin it around, make sure that, oops, don't get in the pipette tip. Make sure as much as I can is the sample. I don't want any vinegar in there because that will change my concentration. So let's pull some more in there. Probably should pull it up. Okay. Spin it around. Make sure that all of this is my sample, my diluted vinegar. Okay. All right. Okay. So now I feel pretty good about everything in here is just the sample. I'm trying to be very careful. I'm trying to get as good of numbers as I can get. So I'm going to pull some sample up. I'm going to take 10 milliliters of our diluted vinegar and put it into an Erlenmeyer flask. I think the lab procedure from last year, I remembered it says 20, but 10 worked good yesterday. All right, so I need my line to be right on 0. Okay, that's pretty good. And then I need to write this down. I need to write down exactly how much of my diluted sample that I am adding. Okay, get the tip. If there's a drop on the tip, get that out. Don't get the extra in the very end. Okay, so this is my sample. The next thing I need to do is I need to add this indicator. Okay, this is the phenolphthalein indicator. This indicator is going to tell us when we have reached the neutral sample. Are you okay? Do I need to close the blinds?
No, she needs the charger. She needs the charger.
Oh, there's 2 over there.
Okay.
Okay. So when we have equal amounts of hydrogen and hydroxide, then this will turn light pink, the indicator. And we'll try to get to that today. Again, we're trying to be very, very careful in our experiment. The indicator turns pink in the presence of hydroxide. So we actually will have like a slightly more acidic solution. But if it's dark pink, that means we have way too much hydroxide. Okay, it's not a 1-to-1. We can only do the math if we know that we have 1-to-1 ratio. Okay, so that's what we're looking for. And when it's light pink, then we know there's 1 hydrogen for 1 hydroxide. They're equal. Okay, and that's really important for us in our calculations. Okay, so I haven't done that yet. I'm going to put 3 drops of indicator to tell me when they're equal. 1, 2, 3. Great. I'm going to swirl that around. Oh, and then the next thing I need to do is I need to look at the bottom of my meniscus. I'm going to get level with it, and then the number line goes down. So make sure that you and your partner are reading it correctly. If you need help doing that, let me know. So it's like 0 going down. So this is between 11 and 12. So it's 11 point something. So it is 11 point, I think it's 11.7. So I'm going to write that down. Let me show you where I'm going to write that down. Are you okay? So I'm writing it here. This is B day, and this is A day. So I'm writing, see how I have 2 decimal places. The burette, we can also get 1 beyond the measurement, which is 2 decimal places. So make sure, that's what I'm going to be looking for. Okay, that's a lot of the points for this lab are coming from sig figs. So make sure you do the correct sig figs. All right, so I'm going to write my initial volume. I will write my final volume. I also need to write the volume of sodium hydroxide. Okay, we'll get there. All right, so I'm going to start titrating. Questions so far? Okay. Sorry. Hopefully not getting motions. All right, so can you see that pink color? We're looking for the whole solution to turn a light pink. Last time it took me 11 milliliters. This time it's going to take me probably about 11. So I started at 11 and a half. 10 from that is like 21 and a half, 21. Okay, so I'm going to go to like 20, and then I'll be more careful. Hopefully my solution is the same concentration. Okay, so now I'm at 20, so I've used 9 milliliters. I know I'm going to use about 11, so I'm going to be more careful as I go further. Okay. If you go way over, you'll have to redo it. You want to get as close to the true value as you can. So our goal in this is we're trying to get to the point where 1 drop will turn it very light pink. So see if we can be patient enough to do that today. Yeah, last time I got it pretty good. So the closer we get to this point, the more base we have. So right now we have more acid because the color is going away. But once we get to equal, then it will start turning pink. Okay. So I'm gonna see this. Okay, so this one, I have a drop in the burette. I don't know if you can see that. You see there's a drop. So if there's a drop at the tip, that's going to count in my value. So I need to get it into the Erlenmeyer flask. I think that one. Did it go in there? I think so. So whenever I do this lab, I think they have auto titrators now. So probably if you become a chemist, no one will ever actually do this. But you have to know how to do it. And you have to know what you're looking at. So this is where we start. And probably if you take a the college chemistry class, or if there's a college chemistry class called quantitative analysis, and you will have to do a titration probably in that one. All right, very fun. How are we doing? We're way past where I thought. Okay, I think we're getting pretty close because it's hanging around for a long time. That pink color is staying. Oops, two drops. Okay, yeah, we're getting pretty close. Okay. Oops, and I have a drop on the side, so let's see. Okay, the other thing I can do is if I think I'm like getting close, I can like write down the value, and then if I go beyond, then I can go back to that value that I was like, oh, I was pretty close. So that's one way you can just make sure that you don't overshoot. Okay, yeah, we're super close. Okay, and this is super boring. Okay, so that was one drop. Now we're at, this is kind of a dark pink. You want like the faintest pink. And this one, so that means I'm going to write down this number. And then I can decide later if I want to go back and redo this one. This one's pretty dark. Okay. So right now we are at 24, just below 24, which is 24. I'm going to say that's 24.10. I'm going to put 2 decimal places, 24.10. And your color will fade, so you just have to like make sure that stays around for about 10 seconds. If you're not sure, if it's like, oh, it's going away, but you can write down the number you have and then add a drop, and then if it goes way beyond, like a really dark, then you can just go back to that number you had already written down. Okay, so now I wrote down on my paper where I started and where I ended, and then how much I actually use is this difference. So I'm going to do 24.1 minus 11.7. I don't know what that is, so I'll do that later. Okay, so let's see, what else do we need to do? Oh, let's do that. So then I'm going to do that two more times. Okay, and then I can decide if they're seeming consistent or if I need to do it again another time. Okay, so my difference here, so this minus this will give me my volume. It seems very hard. I don't know if I have a calculator up here. Okay, do you think you can do that later for your own numbers? Okay, so find the difference for your volume of NaOH that you use. And then moles of NaOH, you're going to use this equation. You're going to do the concentration that you found from here. So this is your concentration of sodium hydroxide. So remember, you're going to do the standardization. You're going to do the math. And then the math can help you do the calculations later. The lab is set up so we do the standardization, and then we do all the math and come back to do this. We're just going to do all the titrations all at once, and then we'll come back and do the math later. Okay. All right. We also need to know the volume of C3H. So this is vinegar. How much acetic acid? How much vinegar did we use? Okay. So we took 10 milliliters and we diluted it into 100 milliliters. And then we used 10 milliliters. So we used 10 milliliters of 10 milliliters in 100 milliliters. So how many milliliters did we use? Mine, I use 1 milliliter of vinegar. Okay. So if you follow that same process, does that make sense? Like in here, I had 10 milliliters. I diluted it to 100. I mixed it up really good, and I took out 10 milliliters. In that 10 milliliters, there was 1 milliliter of the vinegar. Okay. I think the lab procedure tells you to use 20 milliliters. If you use 20 of this solution, then you would have used 2 milliliters. Okay. I am thinking that using 10 milliliters is going to be good because I only used, that's about 10 milliliters of this titrant. That should be pretty good, okay? We don't want to use too much or it's going to take too long and we're going to use too much sample. We don't want to use like if we only use 1 milliliter while we're titrating, then that's not super accurate. So I think the lab goes over that. You want to be in like about 15 milliliters. So we're close to that. Okay, and then you're looking for moles of C3CH. This is vinegar. How much acetic acid? Okay, how much acetic acid here? Well, they should be equal. However many moles of sodium hydroxide we use should be the same number of moles of C3 acetic acid, whatever. Because of this equation, it's a 1-to-1 ratio. I need 1 mole of sodium hydroxide to neutralize 1 mole of acetic acid. So these boxes should be equal, this one and this one. So this is, you're just going to figure out this number and then move it to this number. Okay. And then depending on your dilution, so today I used 1 milliliter of vinegar. So you need to keep track of what you actually do in the lab and write that in the box. And then molarity is just moles. So this one, moles over volume in liters. So this one over this one for acetic acid. And then you find the average. So I would do all the titrations and then go back and do the calculations later. And we can do that if we need to together. Okay, questions so far? Okay, let's jump to the pre-lab. So if you don't have the pre-lab open already, let's go to that. We are in pre-lab 11. The first one is a calculation. So let's do that. And you do need to know that for this lab. You need to know how many grams of KHP do you need so we're trying to get about 15 milliliters of titrant. So use about 15 milliliters of this. So question 1, we're going to do, so we're looking at how many moles are we going to use? Mass of KHP. So we're going to use 15, we want to use 15 milliliters of 0.1 molar sodium hydroxide. So remember, it's about 0.1 sodium hydroxide, but we don't know for sure how many moles of sodium hydroxide. Okay, so this is, remember, molarity is moles per liter. So we need this to be also in liters so that the units match. So this to be liters, we're going to move the decimal 1, 2, 3, 0.015 liters of this concentration. So we're finding moles of NaOH, basically OH. So that is concentration times volume gives us number of moles. So we have the concentration, it's about 0.1 moles per liter times by the volume. That will give us moles. So that ends up with I didn't leave myself enough room. 0.0015 moles. Let's write it again. 0.0015 moles of sodium hydroxide. Okay, so that's how much sodium hydroxide we will use if we use 15 milliliters of 0.1 molar sodium hydroxide. We know that for the acid we're using, this one's KHP, we need a 1-to-1 ratio. So this is telling me if I have, 1 mole of NaOH, I need 1 mole of KHP. Well, we don't have 1 mole, we have 0.0015 moles of sodium hydroxide. So 0.0015 mole of sodium hydroxide will give us 0.0015 moles of sodium or KHP. So this is what you're going to weigh out. It's just going to be in a beaker. Okay. So you need to know how much to weigh out. Well, you're going to weigh out this much. Well, we can't measure in moles, so we have to convert this to grams. Do you remember how to do that? Go from moles to grams. That would get us to a concentration. We're trying to, if we take the moles times by molar mass gives us the grams. So we have moles times by the molar mass. And that was in our instructions somewhere. 204.22. 204.22 grams for 1 mole of KHP. So that will tell us how many grams. Okay, the other thing that's going to ask you for is sig fig. So I'm going to let you do that calculation. Really quick, let's go back to Canvas and we'll come back to this page. So that's what this box is asking. How many grams are you going to measure out? Well, we have 3 sig figs here, and we have 2 sig figs here. So our answer better have 2 sig figs. So let's go back to. Okay. So that's the first box. Okay, while you're doing that, I'm going to stop mine. So in this lab, everything can go down the sink. The base is quite strong. If you get the base on you, just make sure you rinse your fingers off. Probably wash your fingers. And then at the end of the lab, wash your hands. All right, are you ready to do the next one? Okay. Oh, no problem. Let me grab some paper towels for. Someone gave it to me, yes.
I'm just seeing all of
It was gone. I was trying to get some out.
Okay. So the second question is asking about the pipette. So we have a little bit different pipette, but I think it's mostly asking about sig figs. So this will give you, if I go to 0, it will give us 10.00 milliliters. Okay. So you need to make sure for all of your answers you do that. Okay, even this one, I didn't do that. Let me show you. This one, I use 1.00 milliliters of the vinegar. So even on this one, because I use the pipette to move that, okay? So make sure you're giving me the right number of sig figs. If you have questions on that, let me know. We can go over it. All right, then the rest of them are just looking at error analysis. Where could this error, what could this error do to my number? So, and I think thinking about this, what's happening helps us. Okay, there was a little distilled water in the Erlenmeyer flask. So what if I rinse this out? Oh, and I'm going to do another titration, but it has a little bit of water in it. Does it matter?
Yes.
Is that going to affect hydrogens or hydroxides? No. So as long as we don't have acidic or basic water, then that should have no effect. Okay, next question. There was a little acetic acid in the Erlenmeyer flask. So yes, so that's going to change this, and that's going to make me add more base than I should have. So that's going to make it high. Questions on that so far? Okay, next one. There was a little distilled water in the pipette you used for the acetic acid. You forgot to rinse it out with acetic acid. How is that going to affect it? That's going to make it low, yeah. Because you're not adding as much acid as you thought. You're adding less. Okay, what happens if you add 4 drops of indicator instead of 3? Is that changing hydrogens or hydroxides? No, shouldn't have any effect. No effect. What if an air bubble is in the pipette but stayed when you measure the acetic acid? So imagine at the bottom of the tip, remember we talked about the tip? What if there's a bubble there and it just stays there? It will just be the same. It'll be okay. No effect. As long as the bubble doesn't change. What happens? Oh, is that question 8? Yes, the bubble came out. This is different. The answer is high. This one also doesn't make sense to me. I think you're adding less, right?
Yeah, you'd add less. So.
Yes. The quiz that came from Weber State says high. Okay, I agree with you. This one I am not sure because intuitively you've added less than you thought. So it says high, so we're gonna put high. Okay, number 9. Some of the sodium hydroxide drips out. So you're like in the middle of your experiment, and some of it's coming out, but you already wrote down your initial value. So now it's going to be, sorry? It will change it. So it's going to make it higher than you thought. So let's think about this one. So you wrote down your measurement, and then some dripped out, and then you did your experiment. It's going to look like you added more than you thought you did. Yeah, so watch that. Don't let it drip out. Some of them are kind of leaky, so it's a little bit tricky. So do your best. All right, number 10. What if there's a pebble at the bottom of the burette? So what if there's, for some reason, someone put a rock in your burette? Does it matter?
It shouldn't unless it's like leaking stuff everywhere.
Yeah, as long as it's not leaking. Yeah.
Slowly dissolving.
Because we're measuring by difference. Oh yeah, if it's dissolving, and that would be bad. So we're measuring by difference. So as long as we're getting the initial and final volume, that you're just looking at the difference. Okay, so that's fine. No effect. As long as the pebble was there the whole time, it won't change the level. Yeah, you're right. If somebody put it in the middle, oh yes, bring your pebbles. Sabotage each other. That's not very good. Okay, you forgot to add indicator. You added the indicator once you remembered. The solution remained clear, and then you continue the titration. Is that okay? Can you do that? If it didn't change color, it's okay because you're still in the middle of the titration. So you're not to the end point. If you added the indicator and it turns bright pink, that means you're way past the end point. But if it doesn't change color, that means there's more acid to titrate still. So you can still keep going. Yeah, good. So no effect.
Yeah.
Okay, go ahead and submit the quiz. Oh my gosh, that's really strong over here. We should throw that away. I'm like being okay. All right. So what I want you to do right now is I want you to come up with your procedure. You're gonna write that here. Write your procedure. Oops. Write your procedure for the second type of titration that you're going to do, the acetic acid titration. So I want you to write this out. So what are you gonna do? How are you gonna dilute the vinegar? I would use lab 13 from this lab book as a guide. Okay, questions? All right, we have finished all of our topics. So we've got half an hour of class left. Either be working on chapter 12, Alex, finish that by Wednesday. Either work on the lab, look at your old labs that you need to turn in. You could also do your signature assignment or review for the final.